So thank you for having me. My presentation is broken up into two parts. The first part, I'm going to describe the products that we've built for you. And then we're going to talk probably what I think is the more important discussion of how we believe that design automation will be the fundamental thing that will disrupt our industry. And I think that because, one, we're a startup, two, we're in Silicon Valley and talk to a lot of very different people, and three, our background working with a lot of people in the industry, I think that we have a unique perspective, and I hope that we can start a really larger conversation about what design automation will mean for all of us. So with that, when you think about me and my firm, I want you to think about us as being engineers. You are engineers as well, probably, and we all try and go and optimize a problem. And the particular problem that we're focused on is the fact that we want to make BIM more productive, because BIM is an important part of what we do, but it is too expensive and we need to make it cheaper. And so all of our work is really focused on trying to optimize everything that goes into the BIM effort. The fundamental problem we have is that we click too much. If you think about it, an owner pays you to do design, and that results in clicking. And fundamentally, we do that really, really too much. And I challenge you, you can go and download freeware, and you can go and look at this with your teams and measure it. And that's what we did. Using freeware, we had identical modelers do identical tasks for 1 hour. And look at the numbers of how much they're clicking when they're actively doing modeling. Electrical modeling, in this example, on average, 623 feet of mouse movement across screens and thousands of clicks of the keyboard and the mouse. And so fundamentally, again, we are not being productive using our current group of tools. And so our effort has been to try and fix that problem. The interesting thing is that it all began here. I was running a consulting company in California, and I found a beautiful PhD paper written by a guy who was doing his PhD on the F-35 fighter weapons bay. Across weapons bay, you have electrical wiring harnesses and you have hydraulic lines, and they're routed by people clicking a mouse across the weapons bay. And when you're designing a fighter, things are moving around a lot, and you have to go back through and redo it quite a bit. And he wrote algorithms that let you auto-route it across weapons bay. I talked to him, and I convinced him to come on board, and he became part of our team. We acquired his tech, and the last couple of years, we've been spent integrating that work from the F-35 into Revit and creating auto-routing tools. Fundamentally, what is innovation, and how do we kind of view it? We think this is kind of an important thing, and we hope that you can imagine it in your organization so that you can kind of go and use it as well. Innovation begins with an insight. Okay, it begins with some type of connection you make between what you're doing, what you've experienced, what you've bought, or whatever. And through a project management exercise, you take that and turn it into value. The trick here is that the more you do it, the better you get at it. And so your insights get better, your project management gets better, and your understanding of value also gets better. And so I think that we can describe it here, but as we've gone through our personal journey of innovation at our firm, we have found more and more value and gotten very, very good at cycling through and finding this value and going off and achieving it. So our first tool was the F-35 code that we adapted into Revit. And what we did was we turned it into an auto router. And if you had a start point and end point in Revit and parameters, it would auto route clash-free through the Revit environment. And it's integrated into the workflow, and here were our initial examples of how it kind of worked. Again, you have something in the way in Revit, start point, end point parameters, you go through and it'll auto route. We consider this product to be a beta, continues to be a beta, because what we really need to do as a company is create a larger configurator so that we're no longer doing a point-to-point type of routing, but we're trying to route the entire, we're trying to configure the entire floor for a given type of system. But you can see here that we've taken a click-intensive activity and we've turned it into a function, basically, that will connect 2 points in a clash-free ad hoc environment. We have an example here where you take a larger building and you drive the tool in a data-driven way. So rather than do any clicking at all, we provide it with a data file, and it goes through and does the auto-routing sequentially. And in this example, we're doing auto-routing of electrical conduit, followed by pressure piping and then cable tray. We measure the effectiveness or the speed in miles per hour. Our current benchmark, and it varies by the type of hardware you're using, but the typical miles per hour is about 43 miles per hour for how fast it routes. And that's on a MacBook Pro, is our typical computer. So as you can see, it's going through, and we have start points and end points that are predefined, and what it's doing is that's how we control it, by doing those start points and those end points. And again, the greater goal of our company is to create a configurator that'll let you do the entire system at one point, at one time. And we're also, all of that work is actually open to the Dynamo API and other C# API. And so perhaps, someone like the PowerCAD guys or people who already have single-line diagram tools can drive our tool using their tools. And so that's kind of where we're going. While we're going through that kind of auto-routing kind of effort, we realized one day that we had this secret sauce kind of in a way, and that was our ability to manage memory within the building space. A building is a lot more memory intensive than an F-35 or any type of smaller item. And what we realized we could do is we could do dynamic clash detection. And so what we have is ClashMEP is by far our most popular tool. It's being used all over the world. We're closing about 2 enterprise licenses per week now. And what it does is it gives you interactive clash detection directly within Revit. You do not need Navisworks, and you don't need to upload to Glue or to BIM 360. It is directly within Revit. And so here are our early examples, which are a great way of just kind of showing off what it can do. It is spell check for Revit, right? You route, you immediately see your errors graphically with a hatch that is over the element that defines the intersection between the clashing elements. So unlike other tools, you don't take 2 clashes from either side of the duct. You get 1 clash for the volume that you're intersecting. And again, it is fast and interactive. So if you take a look at a larger project and look at how you'd actually use it on a project rather than that test fixture we had, here is a medical office building with LinkedIn files. And the LinkedIn files are turned off, and you go through, and in moments you can have live and interactive clash detection. And so you can see that we're aggregating clashes visually as the hatches up on the top of the screen, in this case the cable tray. And down below, it's aggregating them in a report also in real time. So then using the tool, you can then zoom to clash and go and identify clashes. And so the goal really is to prevent clashes from getting to a meeting. We don't want to talk about clashes in a meeting. We want to deal with them live and where they are. And so from our perspective, our tool magnifies the capabilities of other tools. So if you're in collaboration for Revit, you use our tool and you add clash detection directly into your workflow. We integrated with a company called BIM-Track that does issue management. With 1 click, you can create an issue and talk about it in that meeting or have someone else do it. In a collaboration setting, it's also powerful if you integrate it into Slack or Jira. And we really think that it is really kind of a breakthrough product because, again, real-time interactive clash detection is a better way of working and a better engineered way of working than exporting out and going through another effort. Before I kind of finish up on ClashMEP, there's another part of it that we're working on right now. Because we're integrated into the Revit environment and not hidden behind a file, when a user creates a clash, we know the date, time, and second that they created the clash, and we also know their username. Right? And so all of a sudden we have gamification of coordination. And we can go and do agile methods for how you manage coordination. And we can do all kinds of different measurements and other things. And not only do you know when people resolved a clash, you also know when they made a clash, you also know when they resolved a clash. So it really opens up a lot of capabilities in what we do. While we're doing that tool, we also came up with a concept that we pitched to a nonprofit, which is the AMCA equivalent down in the US called the MCAA. And what we made for them was we made a tool that measures congestion within building plenums. And it's really interesting because we pitched it and they said, we want to give it away for free. And so they funded it through their nonprofit foundation called MSurf. And we're currently in beta right now, and it'll be available as a free plugin for all of you to use however you like. And so what it does is we programmatically find the top of ceiling and then go and, so we break the entire project into grids. For each grid element, we go to the top of ceiling, measure the volume up to the bottom of deck, or whatever your structure is, and then we query and find out the volume of all the MEP or other things within that column, and then we do the ratio of the two to come up with a kind of like an index or a score, a percentage filled of that plenum. And once we do that, we provide that information programmatically to you through a report or through an export, and we also create a heat map. And so I'll show you the heat map. So if you look at this, green is completely unfilled, yellow is 50% filled, red is 90% filled, and blue is 100% filled or more. And so for the first time, just by looking at this, you can look at it and go, gosh, here I'm going to have problems, right? Anywhere where there's blue, let's see if I can use this laser pointer. Where I have blue, I don't have any plenum space left. I'm filled up. I'm 100% filled. Things have to fundamentally change. Where you're tending towards red and orange, you're also probably likely going to have a problem. And so in this image, for example, we're at 50% DD. So if you're at 50% DD and starting to fill up your plenum, you don't have cable tray, you don't have conduit, you don't have braces, you don't have hangers, you don't have whatever the owner is going to add later. And so fundamentally, we can really kind of change the game and begin to put numbers to and visually describe that problem we've all had of 10 pounds of groceries in a 5-pound bag, right? This is the actual visual look at that. And not only that, people like Adam and Cesar can go and programmatically talk to this data and come up with benchmarking and estimating to go through and create predictive analytics for when you're going to have a problem. If you're at 50% SD or DD and you're getting up to a certain value of index at the core of your building, you're likely to have a problem if you're on a healthcare project or if you're on a particular type of project. We're also beginning to come up with insights when you kind of take a look at it all. When you take a look at the overall building, there's actually a lot of green here, right? Buildings are complex, but they're not really that complex. We can kind of really drill down at what the real problem is. And the real problem is the core of your building and the corridors. And so we think that what we're trying to do is change the narrative to go, hey, focus on the core of your building. If you can get that right, everything else will fall in place. And so that's the story of how we're trying to go and do that and take a look at that and create tools that help you go and do that. Another thing that we have, and partially this is because of the crazy people we hang out with and who are in our preschool groups, we're doing machine learning for clash prioritization. And that's because there are a couple of people who do it for LinkedIn and Microsoft around where we live. And what they pointed out was they said, hey, you can go and get free Python code to go and do machine learning. And we go, hey, that sounds great. I've got an application. When you take a look at clashes, what we really want to do is be able to go and rank all of our clashes, so we're only focusing on the top important clashes. And we're not looking at the unimportant clashes, right? And so the important clashes are ones that have money, cost money, need a meeting, have multiple trades, or they're near those areas of congestion. If they're near an area of congestion, I'm not likely able to go and fix it. And so this is kind of our effort to go and do that using clash prioritization. And really, again, we're trying to attack the meeting, get through those meetings, and not have to go through and deal with them. And so using our tools, clashes are automatically created into a list, and they're automatically prioritized, and that really changes how we go about and do meetings. We're no longer running clash tests in what we do. So those are kind of our tools, and given the perspective of going through and learning and creating those tools and marketing them and talking to people, we've refined our view of how we think construction will really be kind of disrupted. And so here is our kind of evidence, and here's our kind of view of what is going to happen, or what we think is highly likely to happen. And ironically, Doug Moore and Tyler Goss, we all know each other, and we're all in kind of the Western U.S., and we didn't really coordinate our presentations, but the funny thing is we're kind of saying a lot of the same things, kind of ironically, and you can pick up on that. We can talk about it later. It's kind of ironic. First off, what really is disruption, right? Disruption is when you have a company or a technology or something, and you leave behind part of the industry, where because of either market dynamics or who you are or how large you are or how small you are, you can't keep up and you get left behind. And that is the classic case of what disruption is. The funny thing about this, though, who do you think wins? The consumer always wins when you have disruption, right? You can think back on all the classic examples of Uber and Kodak, SpaceX, Deck Computer, all these guys, the capabilities of the consumers, we won because of disruption. And so I think that we need to have both a love and a kind of a hate relationship of the coming disruption for AEC. The two examples, did you know that Kodak invented the digital camera? They invented it, and they had, I think, 15 years or longer to figure out how to not get disrupted by their own technology. And then they got disrupted by their own technology right after their patents expired, right? And it is a confluence of things that caused that. And that's what I think is really important to understand. It wasn't any one thing that caused it. It was really a bunch of things that did it. Uber is kind of the same way. Uber disrupted cab companies. Uber has no protection from Lyft, because Lyft has the same business model as Uber. The only thing propelling Uber past Lyft is money from venture capital. And that is also an important thing to understand about how that impacts where we're going to go and how people spend money in order to capture an industry. So there's Malcolm Gladwell popularized it. It was from another guy, but the idea of a black swan. Okay, a black swan is a hard to predict kind of cataclysmic event that happens that fundamentally is a big change, right? And I think that we in AEC kind of view both innovation and disruption as kind of a black swan, right? We're kind of like, we go to conferences and we kind of look around and look at startups and go, who here is really going to have an impact? Who here is really going to do it? And what Malcolm Gladwell in his book Outliers points out is that it's really a combination of lots of different things that add up to create the conditions for disruption and how they kind of happen. And so I want to point out, kind of the big ones that we think of what's happening and what we do, and how it is going to contribute to the coming disruption. First off, the flat productivity curve that everyone brought up that originally was popularized by Teichholz and McKinsey picked up on more recently and updated. And we'll talk about that. The gap in between the current best tech out in the industry and the applied tech that we have within our industry, there's a growing gap. And that is another reason that people who kind of cross that gap are going to be able to gain a bunch of market share. Global population growth, people need more buildings. People need homes, people need everything. You know, there's going to be a growing need for what we build. And then finally, venture capital. And so what I want to do is take a little bit of a dive into both flat productivity and venture capital, and provide a little bit of perspective on both of those. So the amazing thing about this curve, this is the Teichholz curve that McKinsey kind of continued off after 2008. They updated it through 2008. The thing that we don't talk about enough is, so all the other non-farm industries are in red, construction's in blue, construction's basically pretty flat. The amazing thing about this curve is we have added tech to construction. Look how far it goes back. We added CAD, we added cell phones, we added fax machines, we added BIM, we added IPD, we added design build, we added all this stuff, and we still didn't get more productivity out of it. So really what we used probably is to use it to beat each other up, right? We used CAD to make more drawings so we could sue each other more effectively. And you know, we have copiers now, we could write more RFIs, right? And so that is really the amazing thing, is that even though we're adding tech to what we do, we're not actually doing a better job of what we're doing. Buildings are getting more complex, granted, but you know, productivity still isn't growing for what we do. A bunch of us out in California, when we talk philosophically about innovation, we often talk about a guy named John Maycomer. John Maycomer teaches at MIT and Harvard. He is a general contractor as well as a developer, and he's an original investor in a company called Vela Systems that I believe was acquired by Autodesk. He wrote a paper in 2001 that described why innovation doesn't work within construction. And I like to typify it with what I call the innovator's dilemma, or the hot dog problem. Okay? Imagine a construction company finds a caffeinated hot dog. Magically, the caffeinated hot dog increases the productivity of their job sites so that the cost of construction goes down 10%. Okay? Magic hot dog, right? You know, we've never had an innovation that has achieved that type of savings, right? The innovator's dilemma within construction is what happens after you innovate and invest money into the caffeinated hot dog. We give it away. We guarantee the next job by giving the owner a discount on their project to guarantee the win. We take caffeinated hot dogs and we turn it into top-line growth, and then pretty much everyone else acquires caffeinated hot dogs, and we have provided the owner with a better product or a cheaper product. We have won jobs, but we're not able to retain the value of the innovation that we invested in. So why would you invest in innovation as a construction company? Because, you know, marketing is a good reason, but compared to other industries, we have this problem of giving away the innovation because of the dynamics of our marketplace. And if you email me afterwards, I can forward you John Maycomer's paper, and you can look at how he captioned it. The venture capital element, so those two kind of dealt with the productivity problem. The venture capital problem is also very interesting. So venture capital is a business. You know, it's been around for a long time. People have made a lot of money. We have kind of a glorified view of venture capital. How many unicorns have we created as a construction industry? The answer is 1. Procore last year became a unicorn. Okay? It took 14 years for Procore to become a unicorn. They went from startup in 2003 and only became a unicorn in 2017. Okay? And so we've never had a company that kind of hopped out of the gate and said, I've got an idea, here's money, go run, and turned it into a thing that has turned into a progression that turned into a big deal. So if you're a venture capital guy, why would you invest in construction? because we've never proven that we can support that type of value. In fact, you can also go Google this. There's a curious thing about venture capital. It's called the power rule. And to my knowledge, it applies pretty much universally in that if you take a group of startups underneath either one firm or in any kind of sampling, the very, very tail of the bell curve on the top end drives the profitability of the entire stock market or the entire index. And so here you have the top 100 exits ever from venture capital, and it's true here. And if you go and look at individual mutual or individual funds, it'll follow that as well. So again, we as an industry have never been able to, we've been able to create one unicorn. Overall, we've been able to achieve one IPO in Textura. And so again, we're not a good bet in venture capital, even though we're in an $8.5 trillion industry. Drones might be part of the problem, right? $150 million have been invested by venture capital into drones. And how many owners require drones to be used on their job sites? And how many people have had their jobs changed or removed because of drones? And the answer is very, very few, if any. Right? So we have a credibility problem. We told venture capital, every time venture capital goes and puts money into a drone, somebody from construction told them it was a great idea and that it was going to have mass appeal. Right? And the reality is it hasn't been turning out. And so that is definitely a problem. We kind of don't understand the game that we're trying to play. And so why, kind of the question becomes, why will design automation become the thing that will actually be the disruptor within AEC? And the best reason I can think of is because it attacks the fundamental first principles of what we do. And so, I asked somebody here, I said, what is the first principle of construction? What are, Elon Musk has his, what are our first principles for construction? And what is it that we hold dear? What can we always come back to and rely on? Time and money. Have you ever thought that design is actually a critical path activity? Right? We spend all this time doing these critical path analysis, break down columns and by floor and do all kinds of stuff. But really, if you take it further back, design is critical path. And so if we can automate design and make it faster and be able to do things differently, if we can automate BIM, like we started to do, then we're shortening up the critical path, and we're gaining time on every project that we apply it to. Money. Everybody went through this and was shown this graph when we were in college, right? That over the course of a project, you lose the ability to control cost. And this actually has a name to it, and I forget the name of the curve, right? But basically, where does design automation happen? It happens in the earliest phase of the project when you still have time to control the cost. And so if you kind of break down to first principles, design automation has the potential to act on both time and money on everything that it touches. The other thing that you can talk about and why we think design automation will have an impact is because there are actual examples of design automation applied to other industries that have worked really, really well. Semiconductors is one. Animation is another. This is a chip. It actually looks a lot like a building. Right? It actually looks a lot like the things that we go and build for MEP. And in 1980, they actually made things very similar to how we make them. They made them using CAD. They made them using standard libraries. And they used automation from 1980 on to go and attack Moore's Law. And what they've done is continually added on to the amount of tech they have in order to go and chase Moore's Law. And as design automation let them go and do that. Again, this looks a lot like a building, but it's a chip. And what they've done is you remove the substrate, and only reveal the parts of the chip that actually have a purpose. And in this example, you can see how they're modeling for design defects. All the little ridges are manufacturing defects, and they're going through and dynamically testing it without actually testing it on the performance of the chip. And so again, here's an example of an industry that is effectively using design automation to go and test their things before they actually go out. Most important, there are actual companies that have gone off and focused on this and created a lot of value. Cadence is one, and then Mentor is another. And again, you go back to 1980 when EDA for microchips actually started, and they have a multi-billion-dollar company, revenues of multi-billion dollars per year, and the company's very, very valuable because of all their IP. And so our problem isn't much different from this problem. It has direct corollaries to how we should approach that problem. Animation, right? Animation is a digital product, just like BIM is. People used to do animation by drawing by hand, and they got better and better and better. And look at the capabilities now. So on the left is a monster that was drawn for Monsters, Inc. On the right was a movie, I think it was like 5 years later. And you look at how they got better at using animation because they created tools that were digital that let them do design automation. And the interesting thing is that you can only push the animation so far before the monster doesn't look like the monster it used to be, right? And so what happens is you add design automation, and then you lower the number of people you have working on it, so that you can now make a Pixar movie with about 40 people, where before you needed 200. And so again, design automation has affected animation, has direct analogies to how we should be working. So we kind of have a couple of examples of how we're kind of pushing the curve and how we're kind of moving that. I mean, we're not going to be the only one who does it. We know that the industry will probably be flooded by talent of people coming through and doing more and more design automation because we find it so compelling. And it's important for you to realize that kind of to be ready for it and to know that it will happen. Here's an example. Let's see if I can get it to play. Yeah, there you go. HangerWorks by DeWalt is a design automation tool for the hangers and braces of a building. And it's a fantastic tool. It automates all the hangers and braces when you're in Revit and doing MEP. So click of a button per route, it'll optimize the hangers, place it according to rules, look at the load, size the anchor, and do the engineering calcs in the back end for all that equipment. And it's a very, very sophisticated tool. It is $500 per year to use. So it's a fantastic price. DeWalt is actually a client of ours, and we're going through, and the original HangerWorks was created by a company called GTP out of Atlanta, and then we're adding on technology on top of HangerWorks to make it better. And so here you have a piece of, people were doing this by hand, people were laying out tools by hand, and now you have a piece of software that DeWalt wrote that is now automated, and so people really don't have to do that type of calculation any longer. In fact, in a couple of years, they might not know how to do it except in any kind of procedural way. They'll know the concepts of why they do it, but they won't know like how to make a production out of it. And so how we kind of continuously improve upon all that is that we stack our innovation so that the innovation we create today gets added on and supplemented and put on top of each other. And so that's part of, again, the doing innovation a lot really kind of helps you and kind of makes you better. And so let's say that you use HangerWorks for braces and hangers, right? Well, I got a tool that does it clash-free. So what we're going to do is we're going to create an API and tie it into HangerWorks, and all of a sudden, guess what? We have clash-free hangers and braces, right? Pretty phenomenal. You're stacking innovation on top of each other to make it all better. Oh, but hang on. I have an auto-routing tool, right? And it's okay right now. It works pretty well, but we're going to make it better, right? So once we get it better so we can configure an entire floor, I have a way to create MEP systems, at 43 miles per hour per route. Oh, but hang on. if I have an API for manufacturer's content, I can fill across those routes and create manufactured content. And all of a sudden, look at what we've done. In under a minute per floor, per system, we have now gone from LOD nothing to LOD 400. Right? And so this is how we should be operating. We should be working harder at stacking our innovation on top of each other and creating APIs so they all talk and going and attacking the problem and doing good engineering of how we go and do BIM. Coming back to this problem, right? Fundamental problem of corridors. Corridors are important. Let's go write a tool that does corridors. And so today, we have a couple of tools that we can create an algorithm to go through and do a corridor space claiming tool. And we can detect the pinch point, we can do auto routing, we can do clashes, and so because we can do clashes, we can move things around and look at whether or not they're getting better or worse, and come up with methods of doing, of attacking the core and coming up with a generative approach to how you go and do the core. And so we're working on that. And then finally, Summit told me I had to include this. I'm only including it because I'm halfway around the world, and it isn't likely to get back to people I know that we're working on this because it is kind of crazy and kind of actually really insane. But the funny, the business goal of what we're doing is really to create a marketplace that can go and procure things, and you protect it with tech, right? That is really kind of the goal of companies of what we do. And so within a given process, we have design and engineering, and then we have configuration. Design and engineering is the single line diagram. Configuration is modeling and clash detection and coordination and that other thing. And what we did was by happenstance, we found a non-AEC vertical that is kind of related to what we do, that can use all of our tools, and which we can actually do a really good job of automating everything and kind of automating the whole kind of stack. And so what we're doing is it's sophisticated in the fact that it does a lot of things, but we're doing systems integration, we're doing custom engineering, we're doing CFD, and we're doing options, so you can look at various options, and we're doing a Dell-like configurator for how you kind of go through the user experience in order to kind of dominate a vertical and go after it and go, if you're going to go do this thing, you're going to come to our website, and you're definitely going to go and do that. And so this is actually not for BuildingSP. It's kind of separate, and we're keeping it kind of separate because it's kind of a lucrative and emotional market that we're attacking, which is marijuana. It happens to be a big growth industry in California, Colorado, and Washington. It actually has a lot of engineering in it, and there needs to be more engineering in it. And we really can go and create a marketplace where if you want to either get into the market or be able to scale a business, we can have a one-click procurement method for your indoor growing operation. And so we're actually trying to recruit Summit to come and become the CEO. And he and I are going to be Cheech and Chong of the... Again, I'm only going to do this because I'm on the other side of the world. My mom won't find out. So kind of wrapping it all up, and this is kind of probably the discussion over beers, is, we know we're going to be disrupted. We know we need to be disrupted. Design automation is much more compelling than a lot of the other tech that is out there. A lot of the other tech will actually be driven by design automation, because with design automation, the other tech becomes far more interesting. And so we have a couple of views on how things will work. Very large firms are either going to lead the way or they're going to fail. They can lead the way because they have a lot of resources and then go and attack the problem, and they get a lot of attention, but they're a big firm and they have trouble shifting. And so who knows how that will really work out, right? Global sourcing has to happen, right? I mean, the days of not doing global sourcing for our buildings and having communications directly with China and directly with the factory and bringing it over is going to go away. And here's like a really tangible kind of example, I think. This is the Tesla mega factory, 10 million square feet for batteries, right? Going to provide batteries for the whole world, right? Okay. AMCA wrote a specification for MEP systems. There are 250 member companies in AMCA. You guys looked at coil lines. How many coil lines do you think are in the country? 250? Okay. 200 coil lines, right? How many of them are run 24 hours a day? Okay, we're down to 80 coil lines, okay? Do you think China would be willing to build coil lines so they can supply Australia with duct, right? If we shorten up the design period and use design automation to compress how quickly we do BIM, that comes into play. And then you go, well, you can't really ship things like that, right? You can't ship duct in containers, right? Well, we're actually working with a software company to look at optimizing the shipment of duct within containers, right? Because if I have an 8-inch duct, I can change the dimensions subtly and make it an 8.5-inch duct and an 8-inch duct, and all of a sudden they fit in together, and you can go and optimize things like that. And all of a sudden, things come into play that you didn't have before. And again, you're stacking innovation on top of each other to go and achieve that. Software as a sales tool, right? We will give away the engineering in order to get the sale. And that is the reality. DeWalt's $500 tool helps you buy anchors by DeWalt. And that's the reality. And so more and more of that will happen where manufacturers create configurators to go and help you specify their product. And finally, you know, smaller, as teams shrink because of design automation, we can do different things, right? If you have fewer people involved, you can do one company have M, E, P, and S within one house and go off and achieve it. And then we think the opportunity is for companies that are good at a vertical right now is to go and create tools that go and leverage that and go and attack the vertical and try and own it globally. Software scales beautifully. It can be applied worldwide. You can customize it. If you're good at a vertical, go and attack it hard. The reality is the world needs us to build more. So it isn't that we're going to be building less. It isn't that we're going to be out of jobs. We're going to build more because of the tools that we'll build. Is our take on it. One thing that has been brought up about the McKinsey report, where's Australia, right? This is kind of a complicated graph. It's on page 13 of the report, but it basically shows that it measures productivity on the vertical scale and growth of productivity on the XY, or on the X, along. And so Australia is the biggest country that is in the outperformer element here, and they're kind of often alone. And I've been here a couple of times. I have friends who are Australian. You know, I've learned a lot from this trip. You have a very curious market, and I really believe that you guys as a group have the potential to lead the industry in how you innovate because of, one, your connections to Asia and the fact that you have large firms and kind of how you treat each other and how you work with AMCA and with others. And we'd be happy to help you go and do that because you know, like the U.S. is kind of a very complicated market and just very, very different from what you guys have here, which I think is very, very special. And finally, you know, what we're really trying to do is kind of change perspectives of how we do things, right? This is an iPhone, and we look at it as an industry and you go, an iPhone. You go, we should look at a BIM model on it. We should put it in front of our eyes and use Google Glass. We should be able to look at RFIs and do timesheets on it. And the reality is what we should really be learning from the iPhone is how we form an emotional connection to a thing that is really a beautiful piece of engineering that is a piece of plastic that feels like more than a piece of plastic, and it has a great price point and you know, doesn't fail very often and is really just kind of an awesome product. And that is what our goal should be. We should look at these things that we have around us and go, how can we promote that type of thinking to what we do so that we can be better engineers and we can connect with our people better, rather than go, I want a BIM model on an iPhone. With that, I'm open to your questions if we have time. Our website is there along with my email address, and you can find out more information about our products by going on the website. But I hope you enjoyed, and I hope I closed the conference properly.
You were fantastic.